Hi there, my name is Lutz and I work on the OpenAstroTech software suite. It's a clear night today, which is not all that common here in the Pacific Northwest, and I thought we'd do a short walkthrough of how I prepare my OAM for an imaging session. My setup might be considered a bit more elaborate than the average beginner, even though I haven't taken a lot of photographs. I do have a scope, a mono astro cam that's cooled, a filter wheel, an autofocuser, both autopia axes, and an off-axis guider with camera, as well as an onboard PC that's on the mount. We'll be using all these features in Nina, but you can skip over the parts that don't apply to your setup. Or you can just see what these pieces of equipment bring you in terms of ease of use. Alright, let's get started. So I've placed my scope in the driveway, connected power, and the PC is booted. And don't judge my cabling, I'm just a dev. Alright, I'm now connected to the mount PC via remote desktop on my office computer here in the cozy warm office. We'll start the session off by starting OATControl, which I've configured here to pass the -autoconnect command line parameter so that it connects straight away and doesn't require me to click a bunch of buttons. Alright, it's connected, and as you can see, I've also used a feature of OATControl that manages checklists. And I've set up a checklist that shows up as soon as OATControl connects to the mount. You'll notice the first thing to do is take the lid off the scope. And there's a reason that this item is on the list. I've spent way too much time wondering why I'm getting no stars until I realized that I'd left the lid on. Anyway, next thing to do is to home the mount, so it points to the celestial pole. Since I have both RA and deck auto homing available via the Hall sensor support, I'll run that now and wait for the mount to align itself to the home position. As you can see, the RA axis is searching for the Hall sensor in one direction. It looks like it doesn't find it, so it reverses, searches in the other direction, and finally finds it. Then it does the same thing for the deck axis. There's another video that explains how to set up this feature in our firmware, which I'll link to in the comments or below. Once we've found the mount, it's time to connect everything to Nina. And before we do that, let's just quickly go through the equipment tab and see what I have set up. This is my camera, the QHY Minicam 8, which I like a lot, and the attached filter wheel. The focuser uses a standalone board that has the Moonlight firmware on it. Here's the OAM mount, and the guider is PhD2. Now I click the connect button here, which connects all of the devices. Nina goes through them all and connects them. We'll just wait a bit for everything to be connected. Okay, and since my camera supports cooling, I'm going to start that. So we'll click on this and I'll wait till it goes to -10, although it's already almost there. PhD2 is started. Let's move that out of the way. Here you can see the camera cooling to -10 Celsius. As you can see, the checklist here is pretty useful, so I don't forget anything. Like, for example, the next item is switching the filter wheel to luminance, which I've also forgotten before and stared at blank images for far too long, wondering where the clouds had suddenly rolled in. The reason we choose the luminance filter is because it lets the most light through, and that's best for focusing and also for auto-PA or for polar alignment, which is what we'll do next. Alright, so now we go to the imaging tab here and we'll start taking photos in a loop. And we'll just take a look at the stars and make sure they're reasonably round, so in focus, and are not donut shaped or blurry. We can use the manual focuser area here to get the focuser to a good place in terms of focus, or if your autofocus works pretty well, you could just use that to get focused. Since I was focused last night, chances are pretty good we're still focused, and yeah, it does look like It does look like that here. All right, we do want good focus for polar alignment. The better the focus, the better it works, because the more stars polar alignment we'll be able to use for plate solving. Okay, so for polar alignment, we want to slew away from the poles and from the meridian into a clear patch of sky. At least if you use the NINA TPPA for sharp cap, you need to leave it pointed at the pole. We're going to use NINA here because it works pretty well for me. I've used OATControl, this new feature called slew points. I've used OATControl to set up a point to which I want to slew to start TPPA. These points, you can manage them. They're points that are relative to the home position, so you don't have to work out the coordinates, which are going to change night to night. It's just an offset from the home position. So you can see I've got 3 here, one for the zenith, which means the scope points straight up, and I can put a one of those light thingies on for you to do flats. And then there's 2 targets to do polar alignment, one in the east direction, one in the west. If my first one, I usually start with the east one, and if that one fails, then I use the west one. Okay, so I click on this rocket icon here to make it go to the TPPA point, the one for the east. I previously set that up. Once we've slewed there, we go back to NINA, switch to the 3-point polar alignment tab, and make sure we have the settings correct. The direction should be east. We want to start from the current position. We also want to make sure the target alignment is not 0, but it should be 1, which is the smallest amount. And that's just that NINA will actually stop when we get within that tolerance, otherwise it'll just keep going. And then finally we just click the start button here. As you can see, OATControl has detected that NINA has started polar alignment, and it now monitors NINA. NINA is going ahead and capturing the first image from the place where it's pointed. Does a plate solve to determine where the mount is pointing. Yeah, then it goes ahead and slews 10 degrees to the next point. I think it does a settle. It'll take an image and solve it. And as you can see, OATControl is detecting all these events and updating its UI as well. NINA finally gets to the 3rd point, takes a picture, plate solves it, and now it has an error. And now it's calculated the offset that the azimuth and alt needs to be adjusted by. OATControl detects this and waits for 2 solves to be sure nothing is still moving and the plate solve is accurate and isn't working off star streaks. The adjustments aren't synchronized with NINA, they just happen while NINA is looping. Once the 2nd solve succeeds in NINA, OATControl runs the calculated alt and AZ adjustments. And you can see here that the image has star streaks because it doesn't know when the adjustments are happening. So that's why we wait for the 2nd plate solve and also new error calculation. And then once we have that 2nd one, then we'll run another adjustment, and so on and so on. And by the way, this is all fully automatic. I'm not touching anything. I'm just sitting here watching. In the end, a few iterations will run until Nina measures less than 1 minute error. I've set the correction factor for AZ and ALT to not go all the way for the correction. So I like set it to 0.95 so that I don't have backlash issues and just keep going straight into the towards the point. So I'll have a few more iterations. I know some users do it in 3 or 4 iterations, but it looks like it's going to be probably 6 here. It's pretty quick, so I don't mind. Alright, Nina has detected it's within the tolerance that we said, and OATControl also sees that Nina has detected it and auto closes the monitoring dialog. Okay, so usually I would now run autofocus, but I'm still satisfied that the focus is good, so we'll skip this part. It's also pretty automatic and nothing really to explain here. So finally, I think we're ready, and all we need to do now is load a sequence. I'm currently sequencing or imaging the firework galaxy, so we'll load that. Here you can see my sequence. It's a pretty simple sequence. Here's the current target. It's the firework galaxy with the coordinates. It's a little early to start sequencing, but it's good for this demo. We loop until 2 AM. And this stay awake expression helps me end this loop when I'm ready to go to bed by setting this value here, down all the way down here, to 0. Oh, let me set it back to 1. It's still 0 from last time. If it was 0, it would abort straight away. We switch the filter to Loom, wait for a second, slew and recenter. Start guiding with a forced calibration. We're going to recenter every 6 exposures to fix any drift, and we're going to dither every 3 exposures. And then here we have the main loop, which switches to the red filter, waits a second, does a 300-second exposure, and then does the same for green, blue, and luminance, where we do 2 exposures. And finally, I've configured Ground Station to send, that's a plugin, to send a pushover message to my phone when a set of images is captured, just so I know when things are completed, when one loop is done. And then finally this variable I just set to 0 to break the loop and go to the finishing commands, which are also quite simple. Just switch to the blank filter or the opaque, slew to the home position, and then park, which turns off tracking. Then I just disconnect everything and shut down the PC and go outside and put everything back in the garage. Alright, back to the imaging tab. We're also done with the checklist, so let's close that and then just hit play on the sequence. Nina now runs this sequence autonomously, and it'll keep going until 2 and then shut down. Well, stop everything. You can see right now it's running the slew and center command, which slews to my target. It waits for 5 seconds for the mount to settle. Takes a quick 8-second exposure. Plate solves it, calculates the error. The first one is 56 minutes off, which is not too bad. It adjusts the mount, repeats the process until we're within an arc second or 2 of the target coordinate at the center of the image. Now the guiding starts and runs its calibration. We'll just fast forward this. This just takes some time for PhD to figure out the calibration. Okay, now the guider is settling. I can see guiding is not too great. It's a little windy out, but I think it'll be okay. Nina also won't wait forever for the guider to settle. I think it's like a 30-second timeout. So then it just goes to the next step in the sequence and starts the first exposure. And that's it. that's how I set up OAM with OATControl, Nina, and PHT to image the night sky. Let me know if you have any questions in the comments or on our Discord server, and I'll try and answer as best I can. Thanks for watching.